Hello everybody, today we'll be doing a problem called keys and rooms. There are n rooms labeled from 0 through to n minus 1 and all the rooms are locked except for room 0. Your goal is to visit all the rooms, however you cannot enter a locked room without having a key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array of rooms where room is the set of keys that you obtain if you visit room I, return true if you can visit all the rooms, otherwise return false. Okay, so let's take a look at the first example and see how it works. Alright, we have the 0th room. That is our free room, apparently. So we get to visit the first room, and let's say we have visited 0. That's our starting point. Then our keys is now equal to 1. So we visit 1, and we get a key number 2. And then we use key number 2 to get to key number 3. And we use key number 3 to get to room 3, and we have visited all the rooms. So that means that if visited is equal to length of rooms, then we should return that. Yeah, so let's take a look at the second example and see if that's still the case, that what we're doing is correct. So here we are, we get 0 room, we get room 0. So we are visited is equal to 0. And let's say we get our keys is equal to 1 and 3. So we visit room 1 and we get 3, 0, and 1. Those are our keys. So now we take our 3 key, 0, 1, 2, 3, and we visit that room. And we put in a 0 for our keys. Now we have room 3, we have visited that already. We have room 0, we have visited that already. We have room 1. So let's visit that. I think we visited that already too. We just didn't mark it. So now we have room 0, we have visited that already. Now let's return, now that we've done all that, we should return visited equals length of rooms, which is not true. As you have gone through this code, just by going through this code, we came up with a match and a plan, and that's probably to use a queue for our keys and use a visited set to do this problem. Pretty straightforward. So some of the items here is room length must be at least 2. So that is the minimum that we must have. So room length must be at least 2. So that is the minimum. So 0, 1, and maybe nothing, right? So room I dot length could be from 0 to 1,000. Like that's the number of keys that are possible, from 0 to 1,000 keys. Also, the sum of the room dot length is between 1 and 3,000. There are maximum 3,000 keys. I don't see how many edge cases that can occur from. And lastly, there can be 0 to n items of room ij. is less than n, because all these items inside our rooms cannot be more than n. So we cannot have 3 here. That's not possible. So we're not going to go out of bounds. That would have been an edge case that we would have had to check for if not for this particular case. Because if we had a 3 here and we tried to visit 3, we would get an index out of bounds. So with that, there are no edge cases that we need to handle specifically. We just need to make sure that there are visited items and non-visited items. Okay, so let's do a time and space complexity for this. So what is the time? Well, if we have keys, we're going to have to visit every single key and check if it's in the visited or not. And each room could have n keys, n minus 1 keys. So, or I mean, actually n keys, because you can have 1 in 1, right? So you can have n times n is the time for rooms and keys. And space, what is that going to be? Well, it's just going to be n, because we're storing the visited and we have keys. Well, actually, every time we process a single key, we can get n number of keys more. So it's actually n times n for total number of keys possible. So that is possible, but we could bring down the cost of that to O of n. How we can do it? Well, how we can do that is if we ever see visited equals length of room, we can check for that. Like, we can check each time for visited equals length of rooms and early exit without seeing all the keys, right? I mean, we could have n times n keys, right? Total, in our keys queue, but I mean, if we've finished, then let's exit early. But the problem with that is, suppose that there's this one key at the end of all our visited rooms that's at the last room apparently, and we can't get to that room until we get to all the other rooms, and that's n minus probably gonna be like this. It's probably gonna work like this. I'm thinking n times n, and then plus n minus 1, and then plus n minus 2, and so on and so forth. That would be n squared as well. So I don't think we're going to escape n squared, but we can early exit. So that's our reasoning behind it, and we can't escape because of this thing here, because yeah, we're not going to find the key that we need to get to every single visited room. Okay, so let's talk about a match. We can do a queue, and we can do a visited set. All right, and let's talk about the plan. I think we went over the plan earlier. Create a visited set. Create a queue for keys. Visits all keys. And if visited, continue. Yeah, that's pretty much it. So let's do the problem. So first, create a visit set. Visited equals set. Perfect. So create a queue for keys. So keys equals a queue, which is a DQ. Let's just set that up. That way we can do a pop left easily and save some time. Okay, well, so we get access to the first room. So keys dot append room 0 and while keys. I think we can simplify this by putting room 0 into DQ. I'm not sure if it will work, but if it doesn't, we can fix it later. And while keys is key equals keys dot pop left if key in visited, or we can say, yeah, keys sounds good. In visited, then continue to the next key. Otherwise, get all the keys for this room. So room at keys dot append. We're gonna append these keys to our keys queue. I think keys queue would be better, but we already have this DQ here, so we kind of signified what that keys is already. But all right, let's just keep going. And we keep visiting if our early exit, if visited equals length of rooms, return true. Yeah, and then otherwise return visited equals length of rooms. Is that all the code that we need? Well, I think so. Let's run it and see what happens. Okay, so rooms. Key in visited. So unhashable list key is oh, it looks like we got a whole list. So room for room in. I think I need to set this to key, and we need to maybe create a, yeah, okay. So what happens is that this DQ didn't work, and we need to append slowly, like every single key, into our DQ. So yeah, so I could use a pause to figure this out, to find a better way of typing this code out. So it's still a list. Okay, I'm gonna have to take a moment and figure this out by printing out the keys and seeing what's going on with pop left and everything. So I'm gonna pause and I'll see you guys soon. And we're back. So we have the solution here. It's a little different from the code that you were seeing. I fixed a few kind of bugs here with the length of the visited, and also the key in rooms. What was the problem earlier was that we did not pull each key from the room key array, and that caused us to pull an array rather than the key. So here instead, what we did was that we appended each item slowly. To simplify this code, I think we can just do a keys plus the room key, maybe. Let me give that a shot, see what happens. No, there's a problem here. Let's see if it works. I don't think it'll work, but I mean, we'll just have to see. And it does work. So let's submit. That's interesting. I didn't think it would work, but it does, and it's a lot faster. Because we're just attaching two pieces of arrays together to form the keys. Also, if we take out this line of code, it will be slower. So I think, and this is also a base case, so we should push this up here for easier reading. So let's run the submit and see if this is slower. And whoa, it's much faster for some reason. That's unusual. So maybe it's because we're not checking and the test cases are of that. But this should be faster on the average case. So what we're going to do instead is move this to the top like this. And then we can check this statement here, keys.pop, and check if it's in visited. Otherwise, we will add it to the visited like we've suggested earlier. And I think this code reads a lot better. Yeah, so if anything, that's all the code we need to solve this problem. Let's run this code one more time with our and see what the speed of it. So it is the case that without this line, it's much faster. So let's remove this line and let's just submit. I don't know why exactly, but okay, it was just that fluke case. But this does make it look much cleaner code-wise. But this is a base case, and we can read the code pretty easily by just shrinking this line as well. And that's it. So we have completed this problem. If you have code that you would like to share, please comment below and share with us. And let's all learn together. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.